Hi everyone. This week I wanted to discuss a problem-solving question. The reason I chose this question is because a student had come to me with some confusion over this question, and when I read it, I found it to be one of those problems where I really have to step back and take a look at the information that's given, take a look at what's being asked, how everything's worded, and so I just felt like it was a good example of a problem-solving question for us to work through. The question is from the Official Guide for GMAT Review 2017. I understand that most of you probably don't have this textbook, and that's okay. It's an older version of our text, but I did include all of the information about the problem in this presentation, so you don't need to have it. Don't worry about that. You'll still find the presentation useful, and the problem is still certainly relevant. So the question that we're going to talk about is question number 14, and it's on page 22 if you do happen to have a copy of the textbook. So the first thing we need to do when approaching any problem on the GMAT is, of course, read the question. So let's take a look at this question. Of the 84 parents who attended a meeting at a school, 35 volunteered to supervise children during the school picnic, and 11 volunteered both to supervise children during the picnic and to bring refreshments to the picnic. If the number of parents who volunteered to bring refreshments was 1.5 times the number of parents who neither volunteered to supervise children during the picnic nor volunteered to bring refreshments, how many of the parents volunteered to bring refreshments? It's a pretty confusing question. There's a lot of information in there. So I like to approach something like this by breaking down what we know. I'll take some notes and I'll sort of be able to visibly see the information that I know. So we know that 84 parents attended the meeting. We know that 35 volunteered to supervise children. We know that 11 volunteered to supervise children and bring refreshments. And we know that the number who volunteered to bring refreshments is 1.5 times the number who neither volunteered to supervise nor bring refreshments. And of course, what are we trying to find out? I just like to confirm before I start working on a problem what I'm trying to find out. You don't want to go through all the work of a problem to find out that you solved for the wrong variable or you solved for the wrong information. And that number may very well be listed as one of the answer choices, and that's put there intentionally to confuse you. So make sure you're very clear about what question you're trying to answer. So in this case, it's how many of the parents volunteered to bring refreshments. This to me seemed like it was worded sort of confusing. I think the question is, when you look at this, you want to know, are you trying to find out the number of parents in total that volunteered to bring refreshments or the number of parents that volunteered to only bring refreshments? And when you step back and really look at the question, it doesn't specify to only bring refreshments. And sometimes the natural approach to this problem is to solve for that because that's an unknown piece of information. But that's not what we're trying to find out. So we want to make sure when we solve this, we're looking for the number of parents in total that volunteered to bring refreshments. Okay, so I'm a very visual person. So once I've read a problem through, I like to make a picture so that I can see the information in a visual way. So in this case, we have a couple different activities. Some people did one activity, some people did the other activity, some people did both activities, and some people did neither activity. So a Venn diagram is going to be our best bet for a visual picture. So that's what we're going to start with here. As we start putting in the information, one of the pieces of information that we know is that 35 parents volunteered to supervise children, and 11 parents volunteered to supervise children and bring refreshments. Over here on this left-hand side, we want to include the number of parents who only volunteered to supervise. So that whole left circle is going to be the 35. That's the number of parents who volunteered to supervise. To get just this left-hand section, we need to subtract the number of parents who volunteered to supervise and bring refreshments, which was 11. So 35 minus 11 gives us 24 parents who volunteered to only supervised children. Now, over on the right-hand side, we're going to have the number of parents who volunteered to bring refreshments. The whole right circle is the total number of parents who volunteered to bring refreshments. This right-hand section here is going to be the number of parents who volunteered to only bring refreshments. So I'm assigning that the unknown variable X. Now, of course, we also have the number of parents who volunteered to do neither activity, and that one I have assigned the unknown variable Y. So this is sort of all the information that we know in a visual picture that we can see. Now, the question was brought up to me, and this was a really good question. Why do we use two variables here? There are other questions in our diagnostic exam that are very similar, where rather than using X and Y, they use X for one and then something times X or something divided by X for the other variable. And in this case, at first glance, it seems like you could do that. And in actuality, you can do that, because we're told that the number of parents who volunteered to bring refreshments was 1.5 times the number of parents who neither volunteered to supervise children during the picnic nor volunteered to bring refreshments. So as we draw a picture trying to use just one variable, we start off with the same initial information with the 24 parents who volunteered to supervise and the 11 parents who volunteered to supervise and bring refreshments. Then if we still set our number of parents who volunteered to only bring refreshments as X, we can set our other number, which is the number of parents who volunteered to do neither activity, we can set it as a function of X, but it gets very confusing. So if we wanted to do that, this would no longer be the unknown Y, it would be the unknown 11 plus X over 1.5. And when you put that in, it gets really confusing and complicated. So it's easier to set one variable as X, one variable as Y, and then basically use two equations instead of one equation to solve. And we'll walk through what I mean by that. So again, why do we need two variables? It's easier in the long run. We have two variables and two sets of equations, so we can solve for two variables in this case. And we're essentially, by setting that second equation, we're still putting one variable in terms of the second. It's just laid out a little more clearly and easily. So let's talk about those equations that we're going to create. So the first equation is going to be based on the information that the number of parents who volunteered to bring refreshments is 1.5 times the number who volunteered to neither supervise nor bring refreshments. So we had that whole right-hand circle, which is the total number of parents who volunteered to bring refreshments, and that right-hand side was 11 plus X. And that is equal to 1.5 times the number who volunteered to neither supervise nor bring refreshments. That was our unknown variable Y. So 11 plus X is going to be equal to 1.5 times Y. For our second equation, it's just the total number of parents. So our total number of parents is going to be those parents just supervising plus those parents who are just bringing refreshments plus those parents who are both supervising and bringing refreshments plus those parents who are neither supervising nor bringing refreshments. And that equation is 84, which is our total number of parents, equals 24 plus X plus 11 plus Y. So now we're going to solve one equation in terms of the other. So here's our two equations again, 11 plus X equals 1.5 times Y, and 84 equals 24 plus X plus 11 plus Y. So if we take that second equation and we know that that X plus 11 is equal to 1.5 Y, we can go ahead and substitute that 1.5 Y right into that equation for X plus 11. So we're getting 84 equals 24 plus 1.5 Y plus Y. And then we just use our algebra knowledge. We get 60 equals 1.5 Y plus Y, 60 equals 2.5 Y, and Y equals 24. Now, don't make the mistake here of looking to 24 as your answer. We've solved for y. And y, if you remember from our visual representation, was the number of parents who volunteered to neither bring refreshments nor supervise children. So that number was 24. So we're not done yet. We haven't solved for our for the information that we're looking for. Now we're going to go back to our equation and we're going to solve for x. So if we use 11 plus x equals 1.5y, and we then set x equal to 1.5y minus 11, we know y is 24, and we solve that algebraically, we get x equals 25. Again, don't assume that 25 is the answer you're looking for. In this case, we've now solved for the number of parents only bringing refreshments. That's 25. Now this is not what our answer was either, because if you remember correctly, let's take a look back and see what we were asked. What we were asked was how many of the parents volunteered to bring refreshments. Now this would be our answer if we had been asked how many of the parents volunteered to only bring refreshments. But that's not what we're looking to solve. We're looking to find that whole right-hand circle, which was those who volunteered to only bring refreshments as well as those who volunteered to bring refreshments and supervise children. So the total number bringing refreshments is 11 plus x, which is 11 plus 25, or 36. So 36 is the answer we're looking for here. The other way you could find that is the number who volunteered to bring refreshments is 1.5 times the number who neither volunteered to supervise nor bring refreshments. So once you had actually solved for y, you didn't need to go through and solve for x. You could have just done 1.5 times y, which is 1.5 times 24, which also equals 36. Either way is fine. Either way you come to the same answer, and that's 36. So you look through, 36 is answer choice B, so B is the correct answer. If you have any questions about this, please let me know. One thing I do want to mention is if you have looked through the answer in our textbook, the Venn diagram that's provided in the textbook does not clearly match up to the wording of the answer in the textbook. So I would advise not using the Venn diagram in the textbook. The wording is fine, the logic is fine, and the answer that they come to is the correct answer. But that Venn diagram is, it doesn't match how they've explained the answer. So don't use that Venn diagram. Please, if you have any questions about this or any other math questions or any verbal questions, let me know. You can email me, you can post them and ask your instructor, you can come to our live conferences. Just let me know if you have any other questions or need explanations about anything. Thanks.